Okay, let's say m1 through mr are pairwise relative prime positive integers, and a1 through ar are just arbitrary integers. Then the system of congruences, like x is congruent to ai or modulo mi for any I from 1 to r, that's a unique solution for modulo m, which is product of m1 through mr. And the solution should be the sum of these, of course, for modulo m. And in this equation, mi is actually m is divided by small mi. So capital M is product of mi's, and if we just remove one of them, let's say m1, then capital M1 is actually product from small m to small mr, and yi is the inverse of the capital Mi modulo small mi. So capital Mi and yi's inverse relation for mi. Okay, let's try to find that number x. First of all, clearly capital Mi and small mi is a relative prime because capital Mi is from m divided by mi, so we are not going to have mi here, and all these mi's are relatively prime each other. So if you don't have mi in here, then the product of all the other mi's don't have any common divisor with capital Mi, right, and small mi. So this is clear. And because of that reason, the yi must exist, right? Because this is just inverse for small mi for capital Mi, and capital Mi doesn't have any common divisor with small mi, so it should have the inverse of it. So that's guaranteed. Then, since these two numbers are kind of inverse relations, so the product must be 1, congruent to 1 for modulo mi, then this ai times mi times yi must be congruent to ai for modulo mi, because that becomes 1. Then because on the other hand side, the ai, mi, yi is congruent to 0 for mj for any j which is not I, because we don't have any common divisor here for mi, so this becomes 0. Okay, so because of this reason, in this x notation, we can say that x itself is congruent to ai for modulo mi. Once again, for small mi, ai, mi, yi is congruent to ai, but for all the other j, this becomes 0. So for small mi, let's say m1, small m1, this becomes a1, that's clear, and all the other terms must become 0 for small m1. That's how we get this result. Okay, so we found that this satisfies, the x satisfies that condition. Okay, that's good, but we need to show that's the unique solution with modulo m. So let's assume there are two different solutions, x0, x1. Then both of them are congruent to small mi. So is x0 minus x1 is congruent to 0 for mod mi for any I, which means x0 minus x1 must be 0 for modular capital M, which means they are congruent. Actually, x0, x1 must be congruent modulo m.